Hello. Welcome to our discussion of going through the sequential games problem in problem set number 3. I'm going to try to attempt to do this on using the paint feature within Windows. We'll see how well that works. I'm not certain I'm going to be able to be very neat, but I think I can get it neat enough to do the job, even though this is not going to be professional quality by the time we are done. I do not think I will be able to sell this for its artistic beauty. So the game here, the game is between an incumbent firm already in the market and a potential new entrant, and it's for 2 periods. So something to kind of keep in the back of your mind on this, because usually some in the class kind of blank on this or forget this 2-period part. So everything that happens is going to actually happen twice. The beginning of each period, the potential entrant decides whether or not it will participate in the market that period, whether it will be in or out. And that's move number 1, and I'm going to put that on there. So this is incumbent. Or I'm sorry, no, it's potential entrant. I already have to use the eraser feature. So it's the potential entrant. Oh, it's not so bad. Right? And they could be in or out. If, for each period, the incumbent observes the choice. So the incumbent observes what happens, and then the incumbent, if the entrant's in, the incumbent chooses to fight or accommodate. If the entrant's out, the incumbent just has a monopoly, right? It doesn't matter. And then there's the other piece here. So we know if it's in, then the incumbent chooses to fight, so let's extend this down, fight or accommodate. Once the entrant chooses out, it is out for good, which means the game ends right here if the potential entrant chooses out on the first move. I'm not going to fill in the payoffs yet, but we know. First thing I just want to do is draw out the tree diagram here. Okay, so the potential entrant, if they're out, it's over. If they're in, the incumbent chooses fight or accommodate. That's all there is to period 1. But, as we say here, it lasts for 2 periods. So we've got to go ahead and draw in period 2. So, incumbent chooses to fight or accommodate, and then the potential entrant chooses what to do for period 2. So we've got the incumbent moving again. Oops, it's not the incumbent again, sorry. It's the potential entrant moving again. The incumbent just moved. So the potential entrant. So, if the potential entrant is out, we remember, so in the second period, the game is over. The incumbent has the monopoly in the second period, and we'd have some payoffs. But if the potential entrant chooses in, then the incumbent has to decide whether to fight, and we're running out of space on this side, or accommodate, or fight, or accommodate for the 2 spots where the potential entrant is in. This is the tree diagram, minus the payouts, right? The payouts are important, we're going to need them, but I think filling in everything but the payoff first is probably the easiest way to go. Usually I guess that's what I'd recommend. So what are the payouts then? Well, let's look at this up here. There's some that are going to be a little bit simpler, I think, in my view. And the ones that are simpler to do are the ones where the same thing happens both times. If the potential entrant goes out right away, they're out both periods. And the incumbent earns a monopoly both periods. And notice, even though we don't draw 2 periods in here, the game still lasts for 2 periods. But since there are no more choices, we don't draw anything else in. We need to remember it when we deal with the payouts, but there are no more strategic options for either player. Once the potential entrant is out, it's just all over. There are no other actual decisions. What are the payouts? Well, potential entrant earns 0 for each period it's out. 2 times 0, 0. The incumbent has a monopoly 2 different periods. Well, it gets x. X plus x equals 2x. Okay, what about, let's find another case where the same thing happens. We've got in, fight, in, fight. What would happen if it's in, fight, in, fight? Well, the potential entrant, what happens if they're in and it's fighting? Well, they lose $1 each time. So that's -1 each time, so that'll be -2. The incumbent, if they're in and fight, they earn, well, how much do they get? X for monopoly, Z when they're in and accommodate, and they earn Y for each period the entrant's in and they fight, so they earn 2 times Y. Now let's look, there's one other option here where it's the exact same each time, right? And that's where it goes in, accommodate, in, accommodate. So in accommodate, what happens to the potential entrant? Well, they earn $1 for being in each period when the incumbent accommodates. So they'll earn $1 in each period, so they'll earn $2. And, oops, I'm sorry, I drew that on in accommodate, in fight. I need to be careful here. So in accommodate, that's $2. And that's a positive $2 for the potential entrant. The incumbent potential entrant was in twice and they accommodated twice. The incumbent earns Z each time that happens. So that's 2 times Z. I'll draw this, extend that out a little more. Okay, so we've got all the ones that are the same both times. Probably the easier ones. So what happens? We got to just fill out the other 4. Now, with potential entrants in, incumbent accommodates, and then the potential entrants out. Well, what happens for the potential entrant? They get 0 the time they were out, and they get $1 the time they were in and the incumbent accommodated. So that's $1. Move the comma a little closer. $1. And what about the incumbent? In, accommodate, and then a monopoly. Well, they get X when they have the monopoly, and they get Z for each period when the entrant is in and the incumbent accommodates. So that's just X plus Z. Oops, X plus Z. I'm not used to drawing with a mouse here. So, what do we have then in, fight, and out? Well, the potential entrant loses $1 every time they're in and the incumbent fights. 0 when they're out, so that's -1. We know then the incumbent will get, extend this out a little more. The incumbent has a monopoly one of the periods, which they get X, plus they get Y for the time when the potential entrant's in and they chose to fight. So this is X plus Y. Now we have 2 more down here. Both times, actually there is a bit of, these are going to be somewhat similar in a way, because there's an in fight and then in accommodate. Now the other one is in accommodate, in fight. Well, if those sound similar, it's because really the payouts should be identical between the two. And we'll show why in just a moment. So in fight and in accommodate. Well, what about the entrant? They lose $1 if they're in and the incumbent fought, and they gain $1 if they're in and the incumbent accommodated. So they lose $1 one period, they gain $1 the other period. That's 0. What about the incumbent? They earn Z when the entrant's in and they accommodate. They earn Y when the entrant's in and they fight. So it's Z plus Y. So it's Z plus Y. And actually it's the exact same over here. In accommodate, in fight. So it's 0 and Z plus Y. I'm going to see if I can get this to look just a little bit neater. It's obviously still pretty messy, but we can make it look just a bit nicer. Okay. I'm actually going to save this just in case something happens. Tree. This is the tree diagram, right? So this is the first part of A. Draw the extensive form of the game. Now what we need to do is use backward induction. to solve? Well, the last move is the incumbent. Oops, we've got to make sure we label the incumbent there. The incumbent chooses to fight or accommodate, right? So if we're in the case where potential entrant went in, the incumbent fought, potential entrant goes in again, what does the incumbent want to do? Well, the incumbent's looking at 2y or z plus y. Which one would the incumbent like? Well, z is greater than y, as we're told. So z plus y must be greater than y plus y, so the incumbent would accommodate. What about this spot over here? We've got the incumbent could fight or accommodate after entrant moved in, incumbent accommodated. Potential entrant moves in again. Do they want to fight or accommodate? Well, here they're looking at z plus y, or 2 times z. Well, z is greater than y, so z plus z is greater than z plus y. The incumbent would want to accommodate. Then we can move up a level. All right, we could move up a level in our tree diagram. So we know that if the potential entrant moves in, the incumbent fights. The potential entrant then could go in or out. If they go out, they lose $1. If they go in, we know that the incumbent will accommodate and they'll get 0. Well, they're going to want to move in, right? Because 0 is better than losing $1. What about on the other side? The potential entrant goes in, the incumbent accommodates. Potential entrant could go in and get $2 or out and get $1. Right? We know they'd get 2 because we know the incumbent will accommodate. Well, potential entrant will take $2 over $1, so they'll move in. Now we're looking at what does, if the potential entrant moves in the first period, what does the incumbent want to do? They could fight or accommodate. If they fight, we know it will then go in accommodate, and the incumbent would earn z plus y. If they accommodate, we know it will go in accommodate, and the potential entrant, or the incumbent will earn 2z. So it's z plus y versus 2z. Well, let's go back over here, right? Z is greater than y. Z is greater than y. Z plus z is greater than z plus y. Incumbent's going to accommodate. And now we're up to the very first move of the game, the potential entrant. They could go out and they get 0, or they could go in, and we know it will then go accommodate, in, accommodate, and they'll get $2. $2 beats nothing. Potential entrant joins in. So, what would you write out here? The subgame perfect Nash equilibrium. It's important that you write this out in your answer. Don't just say it's the Nash equilibrium, because that's not quite correct. The subgame perfect Nash equilibrium means you were at the Nash equilibrium in every single subgame. So the subgame perfect Nash equilibrium, the potential entrant enters the market both periods, the incumbent accommodates both periods. And we have now solved for part A. So what about part B? The game is modified, and there's a credit constraint, as we say here. If the potential entrant takes a loss in the first period, they can't jump back into the game. They're just out. So, what would happen there? Well, that means that doesn't occur if they go out right away, right? They're already out. Or if they go in and the incumbent accommodates, everything is the same. But if they go in and the incumbent chooses to fight, the game is over. It's in terms of the strategies, and we can work on our payouts. So what we could actually do is we could erase everything. Let me go over here. We could erase all of this, because this for part B, and you don't want to erase it, you just want to start a new one, because you will want to keep this in your notes. But you'd want to rewrite the decision tree, but it will look identical except for this strand where the game ends after the incumbent chooses to fight. Now, if you kept your old game, it's actually going to be one of the payouts that you had before, but I'm going to go through it again to figure out what the payouts are. So here, potential entrant goes in and incumbent fights. The incumbent is out in period 2 where they get 0. In period 1 they lose $1, right? Because the incumbent fought, so their payout is -1. And what happens for the, what kind of payout does the incumbent get? Well, potential entrant was in and they fought, which we know is a payout of y. The incumbent earns y for each period in which the entrant is in and the incumbent fights. So that's y, plus one period they have a monopoly, and that is x. So it's y plus x. So what happens here? Well, I'm going to erase what we have here, these circles, just in case we find a different answer. Because we need to solve for the subgame perfect Nash equilibrium now that we have these new payouts. We do know that if we get to this point, the potential entrant would move in and the incumbent would accommodate, right? Nothing there changes. But what we need to do now is examine the case. What would the incumbent choose to do? Would the incumbent choose to fight or accommodate? And what they know that if they accommodate, they're going to get 2z. If they fight, they'll get y plus x. So the question we have is y plus x greater than or less than 2z? And, well, wouldn't you know it, we actually have that information in this. X plus y is greater than 2z, which means the incumbent gets a greater payout if they choose to fight than accommodate, which means the potential entrant is considering whether to jump out immediately and get a payout of 0, or to climb into the game. Jump into the game, open up, and get a payout of -1, right? Nothing is better than losing. So the subgame perfect Nash equilibrium of this new game with the credit constraint is simply the potential entrant chooses out in the first period. That's it. That's the whole game. So I hope this was helpful. I hope my scribbles show up well enough on the video that you know what I'm doing through MS Paint. Maybe I'm going to have to try to find a different program, one of those programs where I could actually use my handwriting, which isn't necessarily great, but it's a lot better than this. But I'm hoping this helps you understand how the game works, how this sequential game works.